Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lutfi Fikri bin Cik. My metric number is AD220033. I'm going to explain about the theory of the experiment. The theory of a cooling tower experiment is based on a heat and mass transfer principles, where hot water is cooled through evaporative cooling. When water is distributed over the field media, it comes into direct contact with air, transferring heat and moisture to the air. This process lowers the water temperature as sensible and latent heat are removed. Key parameters such as temperature difference, wet bulb temperature, and flow rates of water and air are analyzed to assess the cooling tower's performance. The experiment aims to evaluate cooling efficiency, effectiveness, and the impact of variables like air velocity and water flow on heat removal efficiency.
Procedures of experiment. There are two procedures for this experiment: setup procedures and the general shutdown procedures. These are the setup procedures for the experiment. The steps will be shown and explained in the video later. General shutdown procedure. Switch off heaters and let the water circulate through the cooling tower system for 3 to 5 minutes until the water cools down. Switch off the fan and fully close the fan damper. Next, switch off the pump and power supplies. Retain the water in the reservoir tank for the following experiment. Completely drain the water from the unit if it is not in use. Ensure all valves are closed and the pump bypass valve 3 is open. Fill the load tank with distilled or deionized water up to 30 cm on the level scale. Add distilled or deionized water to the wet bulb sensor reservoir to the fullest. Connect all appropriate tubing to the differential pressure sensor. Install the appropriate cooling tower packing for the experiment. Set the temperature set point of the temperature controller to 50 degrees Celsius. Switch on the 3 kW water heater. Heat the water. Switch on the pump. Slowly open the control valve and set the water flow rate to 100 lph. Fully open the fan damper and switch on the fan on maximum speed. Check that the differential pressure sensor reads when the valve manifold is changed to measure the orifice differential pressure. Let the unit run for about 20 minutes for the float valve to adjust the load tank's level correctly. Refill the makeup tank as required.
Assalamualaikum, and my name is Muhammad Nabi Hakimi bin Muhammad Taufik. My matrix number is CD2201 and 99. So today I'm going to explain about observation of cooling tower experiment. In the cooling tower experiment, we were able to monitor how the cooling tower cooled the hot water supply to it. Dispersing water as it passed through the channel of the tower, the air impinged upon the water during the flow process, permitting the heat of the water to transfer by evaporation the air. It was also found reflecting at inlet water temperature was slightly higher as compared to the outlet water temperature, which show effective cooling has been done. Other parameters like the rate of airflow over the heat exchanger, the rate of water flow, the humidity, and the temperature had strong impact on the level of cooling. Cooling performance was better at desired airflow rate and an evenly spread layer of water of the tower field. That's all from me. Thank you.
So this is a result what we get from this experiment.
Next, conclusion. According to the parameter of heat discharge by water heat absorbed by air sensible heat and evaporation loss, the cooling tower system can be assessed its efficiency, which an efficient cooling system means that it takes less energy, hence saving cost when cooling tower in air cooling system experiment. These parameters are very important for the efficiency of the cooling tower. Finally, to enhance the performance of the cooling tower in the experiment can make change such as altering the air flow rate and water flow.